Heat exchangers are elements that transfer heat from one fluid to another through a contact wall, with the purpose of better use of heat. In this case, the exchanger contains a double pipe. We can see its features in the next image. There's a diagram on the front of the equipment, which indicates that parallel flow is available, meaning that the two fluids circulate in the same direction, also with counterflow, meaning the fluids circulate in opposite directions. On the right side of the equipment, where the magnifying glass icon is pointing, there are cooling fluids located. They can be water or air, while on the other side are fluids for heating, which can be hot water or steam. There are also some valves in red color indicated in the image. These help us to make changes in the direction of the flow, according to the requirements in the mentioned diagram. At the bottom of the equipment there are some more valves, all with the same function. We can see that there's also a series of thermometers. They are placed in the corresponding pipes and help us to continue the analysis. There are 18 in total, all numbered and color-coded. From 1 to 9, they correspond to measure hot temperatures with the red needles, while from 10 to 18 correspond to measure cold temperatures with the blue needles, except for number 16, which had to be replaced, but it has played with a number that helps us identify that it corresponds to cold temperatures. In the lower part of the equipment, there is a tank that contains hot water. That's the reason why it has a thermometer, since it helps us to measure the temperature of the water, which is heated thanks to the resistances that we can observe on the side of the tank. In the upper left side, the manometer is located. It indicates the pressure of the steam in case it is used, which is very important for safety, since this equipment has a limit of the amount of pressure it can handle. In this image, we can see the numbers and colors corresponding to the 18 thermometers. Later, you will see their function. Here, we also have the diagram. If the device were in a parallel flow configuration, we have to take into account the thermometer 1 and 10, since 1 is the entry of the hot fluid and 10 the entry of the cold fluid. Throughout the journey, the fluids exchange heat until they reach the end, that is, thermometers 9 and 18. This allows to draw a behavior curve and thus observe how much heat is being transmitted by obtaining the heat transfer coefficient. If it were a counterflow configuration, then we must take thermometer 1, the entrance of hot fluid, and thermometer 18, the entrance of cold fluid. In the same way, it allows to draw a graph where we can see the transmission of heat. However, this graph will be different from that of the parallel flow, since we will realize that the coefficient is higher, which allows to understand that the heat transfer is more efficient at counterflow. It is important to identify the best moment to take measurement. That's the reason of the preparation. First, you must start with the constant cooling and heating flows. From the moment you notice that the temperatures begin to stabilize, you must wait for 20 to 25 minutes. After that time, measurements can be taken. To do it manually, simply look at each thermometer and note down the temperature it measures. There is also the possibility of the automatic form. In this, the thermocouples of each temperature will be designated to a data acquisition card that can be put in the computer, where all the temperatures and transfer coefficient will be recorded. After you obtain the two types of results, you will have to make a comparison between them. Surely, there will be a variation, which will help you to obtain the percentage of error between the manual and the automatic calculation. This equipment was recently repaired. It is important that you take care of it and use it responsibly, and with the appropriate measures, not only for material good, but for the safety of the classmates and teachers.